Hi students, we left off talking about covalent bonds, and I'm going to briefly go back over these two slides before we move on and take a look at how to name covalent compounds. Can I move you? Okay, so covalent bonds are formed when we have atoms that of two or more nonmetals. And what they're going to do is instead of donating or gaining electrons, they're going to share electrons to make a covalent bond. So we have those valence electrons that are going to be shared because everyone wants to have noble gas electron arrangement. So if we take a look at carbon dioxide and carbon monoxide, notice that we have two elements. We have carbon and oxygen, but they can make two different types of compounds. So because we can have the same two elements making more than one compound, we have to have a different way to name these compounds. So if we share one pair of electrons, we have a single covalent bond. If we share two pairs of electrons, a double bond. If we share three pairs, it's going to be a triple bond. So how do we name covalent compounds based on their formula? Well, if you're looking at a compound that has just two different atoms, you're going to name the first nonmetal. It's going to keep its element name. And then the second nonmetal is similar to ionic compounds in which you keep the first, the root of the name, you drop the ending, and you add "ide." Well, the only major difference between ionic and covalent naming is that for covalent compounds, you're going to tell how many of each atom you have in the formula by indicating a prefix. And so the prefixes are here, mono through deca. And it doesn't matter if we're talking about the first or the second atom. Now, the only thing is mono. We don't use mono for the first element if there's only one atom of that type of element. So if we see here, we've got carbon and oxygen. We have carbon with two oxygen. That gives us carbon dioxide. Carbon plus one oxygen gives us carbon monoxide. And we use the prefix di or mono to determine the number of oxygen atoms present. So when we have something like nitrogen monoxide, we drop that ending O in mono because we won't have two O's in mono. So it's not monoxide, it's monoxide. If it was tetra oxide, it would be tetroxide, not tetraoxide. So here we have some common molecular compounds and what they're used for. So let's try and name these molecular compounds. Let's see, we have nitrogen and we have nitrogen and three chlorines. Well, remember, the first atom, you're always going to give it its name, nitrogen, right? The second atom we have here is chlorine, and we have three of those. So the prefix for chlorine is, the prefix for chlorine, or for three, is tri. So trichloride is the name, okay? Let's take a look at the second one. We have, that should be written as B2O3. Well, first you've got to find what B is on the periodic table. What is it? Boron. And we also know that O is oxygen. Now we have to add their prefix, diboron. tri. Tri, is it trioxygen? No, it's trioxide. Okay? Okay? Let's write the molecular formula for diphosphorus pentoxide. Well, phosphorus has what letter or what is its symbol? P. And di tells us that we have two of those. Pentoxide, oxide stands for oxygen, and pent is 5. So P2O5 is going to be the formula for diphosphorus pentoxide. So how do we know whether you have a covalent compound or not? Well, just like when we looked at an ionic compound, we know that it's going to be a covalent compound if I have two nonmetals. So anytime you're given a formula like this, and you see both of these are nonmetals, then you know this is more likely a covalent compound and not ionic. Okay? So how do we name it? You've got the first nonmetal, second nonmetal. You're going to use the prefix to match the subscript before the name, and use the prefix to match the subscript before the element name, and you end in I for the second atom. Okay? All right, so let's compare the two once again. How do we know? I can't put myself in a place where you won't see the whole slide. So you'll just hear me. A compound is usually ionic if the first element in the formula is a metal or a polyatomic ion, ammonium. So you know that it's going to be a covalent compound if the first element in the formula, sorry guys with the picture over there. Oh, here I am. So if the first atom in the formula is a metal, it's most likely an ionic compound. If the first atom in the formula is a nonmetal, then it's usually going to be a covalent compound. So let's do study checks and select the correct name for each compound. Well, here we've got silicon and we've got chlorine. We've got one silicon and 4 chlorines. So it can't be a silicon chloride because we've got 4 chloride or chlorine atoms. Can't be tetrasilicon chloride because we don't have 4 silicon. The answer is C. Silicon tetrachloride is the answer because we've got 1 silicone atom and we've got 4 chlorine atoms. So silicon tetrachloride. Well, let's take a look at P2O5. Well, that's the one we just looked at a minute ago. P stands for phosphorus. We have 2 of them, so that's diphosphorus. And O stands for oxygen, and we have 5 of them, so that's pentoxide. So the answer here is diphosphorus pentoxide. All right, so quiz yourself. Name the compound SO3. Can it be C? It can't be C because when you have Roman numerals, that's only for a variable charge metal. Sulfur metal? No, it's a nonmetal. So is it the sulfite ion? Well, it can't be the sulfite ion because we don't see any charge here. If there was a -1, then it would be the sulfite ion. Okay, so we are left with A and B. Sulfur oxide, sulfur trioxide. Well, sulfur oxide is not quite how many oxygen atoms we have. So what's our answer? Oops, I didn't give the answer. Sorry. Oh my goodness. So the answer is sulfur trioxide. Name the compound Cl2O7. Well, first you know it's chlorine, and then the second name is going to be oxide, but we've got to give the prefixes. So we've got how many chlorines? 2, and we've got 7 oxygens. So that's got to be, oh goodness, sorry guys, can't be C because it doesn't tell us how many chlorines we have. So the answer is A, dichlorine heptoxide. All right, next study check. Identify each compound as ionic or covalent and give its correct name. Well, for A, we have SO3. Well, first we've got to look at the first element. Is it a metal or non-metal? Well, sulfur is on the left-hand side of the right-hand side of the periodic table. So it's going to be a non-metal. So this has got to be covalent. What now is the name since we know that it's covalent? Well, it's going to be, there's only one sulfur. So sulfur. And we have how many oxygens? 3. So sulfur trioxide. B, BaCl2. Well, what is Ba? Is it a metal or non-metal? Well, it's a metal. So if the first atom is a metal, then this must be an ionic compound. And because it's ionic, we don't name it with these prefixes, we just name the ions. So this is barium, what? Chloride. Can you see that? Yeah. All right, let's take a look at C. C is NH4, 3PO3. Well, remember the rule says that it's ionic if it begins with the metal or the ammonium ion. Well, this is the ammonium polyatomic ion. How do we know that it's a polyatomic ion? Well, it's in these parentheses and it's got a subscript around it telling us that we've got 3 of them, right? So this is going to be an ionic compound. And what's the name? Well, I've already given you the name. You guys need to memorize that slide with these names, right? So this is ammonium, and this is phosphite, PO3, not PO4. If it was PO4, it would be phosphate, okay? Let's take a look at the rest of them. Got this up here? I'll leave C there. Let's look at D. D is Cu2CO3. Well, Cu, we know Cu is copper, it's a metal, so this has got to be an ionic compound. But remember, Cu, is it a representative metal? No, it's not. It's a transition metal, so it has a variable charge. Well, what is this polyatomic ion right there? You've got to know this polyatomic ion name. And it is, so this is the carbonate ion, and it has a -1 charge. So if we know that this is a carbonate ion and it's got 1 charge, that can tell us why we have this here, right? I'm sorry, it has a -2 charge. Yes, it does. It has a -2 charge. So that tells us why we have this Cu2. So if carbonate is a -2, and I need 2 coppers, then that must mean that I've got copper 1. we have N2O4. Well, what is nitrogen? Is it a metal or a non-metal? It's a non-metal. So if it's a non-metal, that means that we've got a covalent compound. And how do we name covalent compounds? Based on the number of each atom. So we've got 2 nitrogens, so that gives us dinitrogen. And we have 4 oxygen, and it's really tetra, but because we have oxygen, we're going to say tetroxide. Okay? Oh, and that's it. So make sure you practice. Make sure you practice. Do all the practice sets in the textbook. Um, Practice the quizzes. Practice these problems here. And email me if you have any questions. And I will see you on Thursday. Happy studying.